In this video, we are going to find the derivatives of functions involving the natural logarithm of x. We will mostly use the power rule, chain rule, and product rule. This is the product rule right here, and this is the chain rule. For the first problem, let's find the derivative of the natural logarithm of the square root of x squared plus 1. So what we're going to have to do here is apply the chain rule 3 times. So we're going to have the derivative of the natural logarithm, which is just 1 over its argument, multiplied by the derivative of the inside part, which is just 1 over 2 times the square root of x squared plus 1, multiplied by the derivative of the inside of the square root, which is just 2x. Putting this together, we have 2x divided by square root multiplied by square root is just 2 times x squared plus 1. We can cancel these two, and we're left with x divided by x squared plus 1. So all we did here was apply the chain rule 3 times, and this is the final answer that we got. For the second problem, let's find the derivative of the natural logarithm of x squared multiplied by sine of x. So we're going to have to apply the chain rule and then the product rule. So let's go ahead and do that. The derivative of the natural logarithm of x is just 1 over x, and x in this case is x squared multiplied by sine of x. We're going to be multiplying this by the derivative of the inside part. So we're going to have to apply the product rule. We're going to have x squared multiplied by cosine of x plus 2x multiplied by sine of x. This is equal to x squared times cosine of x plus 2x times sine of x all over x squared times sine of x. Notice here we have an x squared here and an x here and an x squared here, so we can cancel one factor of x, and we're left with x times cosine of x plus 2 times sine of x divided by x times sine of x. And that's the final answer to this problem. For the third problem, let's find the derivative of the square root of the natural logarithm of x cubed. What we're going to have to do is apply the chain rule 3 times. So we're going to have the derivative of the square root of the natural logarithm of x cubed. So we're going to have to bring the 1 over 2 down to the front, and then we're going to have to subtract 1 from the power. So we'll have the natural logarithm of x cubed raised to the minus 1/2 power multiplied by the derivative of the natural logarithm is just 1 over its argument. We're going to be multiplying by the derivative of the argument of the natural logarithm, which is just 3x squared. And we can simplify and put this together, so we can bring this down to the bottom. And this is equal to 3x squared divided by 2 multiplied by x cubed divided by the square root of the natural logarithm of x cubed. And this is equal to 3 over 2 times x multiplied by the square root of 3 times the natural logarithm of x. All we've done is use the power rule here to bring the 3 down to the front. Now this simplifies even further. We have the square root of 3 over 2x times the square root of the natural logarithm of x. And that's the final answer. For the final problem, we're going to find the derivative of tangent of the natural logarithm of x to the 4th power. So we're going to have to apply the chain rule 3 times here. The derivative of tangent is secant squared, and the argument's just the natural logarithm of x to the 4th power. Now the derivative of the natural logarithm is 1 over its argument, and the derivative of x to the 4th power is 4x cubed. Now multiplying this together, we have 4 multiplied by secant squared of the natural logarithm of x to the 4th power divided by x. And that is the final answer to this problem. I hope you found this useful. Make sure to like and subscribe for more content like this.